Hi and welcome to the session, Practical Pros and Cons for Replacing Swing with JavaFX and Existing Applications. Contrary to most sessions you'll see about JavaFX, we're not going to start by showing you Scene Builder and FXML and yellow circles and 3D. We're going to assume that you have an existing application, an existing large application that's been in production for some time, so that you have a very heavy investment in it, and that you would like to use some of the goodness of JavaFX, and that you're wondering which parts of JavaFX are the goodness that are relevant for the applications that you've created. And that's really the setup for this session. Stated in other words, according to the abstract, JavaFX provides a whole bunch of promising things on the UI layer. Not only which parts are usable in our existing applications, not only how, what strategies, but also just asking the question, is it ready? And what does ready mean? And together with a group of people who have actually been trying this out in the real world, you'll hear from our combined experiences. Of course, one is almost automatically in a defensive position when mentioning the desktop, because every single keynote at every single conference that has anything to do with programming of any kind assumes that everyone is or will be or should be on the tablet or on the mobile phone or in the browser. And I'm sure that, the fact that we're here, all of us probably have some question marks to that kind of perspective. But at the same time, all of us, I'm sure, are interested in tablets and mobile phones and browsers in combination with our desktop applications. That's what I've found in interacting with a lot of desktop developers. I've found very few desktop developers who say, we're going to dump the desktop and move everything, our entire air traffic control system, to a mobile phone. In fact, I've never heard anyone say that. But I've heard people saying, that's very the same people, yes, but there is a use case for the tablet and the mobile phone and the browser in our scenarios. So just as a refresher, perhaps superfluous, but just to go through some common use cases. So here we have Gephi, a Duke's Choice Award winner. By the way, Swing is the largest winner of Duke's Choice Awards in the past few years. 4 this year, I think 4 or 5 last year. For example, last year, James Gosling's liquid robotics application. But anyway, Gephi, a network satellite or network analysis application. OpenSim, one of the Duke's Choice Award winners from this year. Musculoskeletal analysis, prediction of operation outcomes before the person gets carted into the surgery room. Other applications for visualizing various things, the farm management application, AgriSense, that won the Duke's Choice Award last year, that you're going to see more about today. Scientific applications. Not only do scientific type programmers not have access to a server, of course they're dealing with heavy data. And so it's much more logical for them to be on the desktop. Here, in this case, a rat brain analyzer, very relevant in certain sectors. Air traffic control system, of course, this is always going to be a desktop type application, a prototype application for the EU, for police forces around the EU. They can enter data about a particular weapon that's been found, and then find all the connected people to that weapon and all the objects that are connected to those people, and make an entire graph based on a particular crime-related object that's been found. NATO last year won a Duke's Choice Award. Air traffic management, the whole European airspace is managed through NATO's swing-based system. Behind, you see another screenshot added again in the biological world. Of course, stock trading, high-frequency trading, banking. In the banking world, desktop is very large. Again, in the back office, of course, you don't see banking application screenshots on the website of the various banks. It's not interesting for the end user, so it's hidden behind the scenes. So, fair questions to ask. So we know that the desktop is prevalent, it's everywhere. These questions to ask, and we're going to ask them up front. Normally a session about JavaFX, you see wonderful things and wonderful promises, and your application will be wonderful. And slide 50 of the 50 slides is, oh, and by the way, this and that. So we're going to say up front, these are the questions that we have and that we'd like to answer. First of all, is JavaFX ready to be used at all, and what does ready mean? If it means drawing a yellow circle in my application and moving it from left to right, then that's not ready. Can we use it? If it's ready now, maybe I relied, as the previous session was clear, I relied on JavaFX 1, and then I had to rewrite my application completely to JavaFX 2 because of completely backward incompatible change. How to mitigate those risks, how to buy into JavaFX but still be prepared for changes coming up. Secondly, okay, it's ready, but is it relevant for what I'm doing? Is all of JavaFX relevant? Which parts are relevant? What is the place of JavaFX in the application that I have? So maybe I don't have a very graphic-oriented application. I have a banking application. So which parts of JavaFX are relevant there? And finally, assuming that we say, yes, it's ready, yes, it's relevant, and we've chosen the pieces we want, how do we actually integrate those pieces into our applications? And a slight mixed metaphor, don't reinvent the wheel if others have walked that road already. We're going to go through 3 scenarios. First of all, Sean Phillips showing a NASA-oriented application, a Jig's Choice Award winner from this year, Timon Feenstra showing the AgriSense project, a Jig's Choice Award winner from last year, and Rob Chapelovsky with an application that will probably be a Jig's Choice Award winner next year. Who knows? But the common factor in these particular applications, they're all Swing, but the commonality is they're all very large, and there's very heavy investment in Swing. And they're very large. They're based on the NetBeans Platform. And if you want to know more about that, we have a session about that with a whole bunch of people, also some here, Bruce and others, talking about the NetBeans Platform, showing real examples and what you gain from that. So without further ado, we're going to switch to the first use case.
Thanks, Gurchan. Hi, I'm Sean, and I just want to emphasize that the tool that I'm about to describe and show you has been in development for a little bit over 2 years, and it's been part of a mission that's been in development from a software and data production standpoint for 5 years, and been in planning for almost a decade. So you can imagine the trepidation that I faced with trying to roll JavaFX into that design. The original design had no inclination of JavaFX whatsoever, because it was a very data in, data out process, very procedural. This is a mission control tool. It is in mission operations at the Goddard Space Flight Center in Maryland. It will support a November launch of 2014 for the MMS mission, which measures the magnetosphere. It's very complicated, the mission operations setup. I mean, we're talking, I have here the GGSS highlighted, but there's all these other boxes are very complicated, and each one of them are developed by different groups. There's a ton of automation in there and a ton of communication. So very complicated. And it's all to support the general science of how the heck does the magnetosphere work, how is it reconnecting, and how long do we have to live before it collapses in 1 billion years or whatever, and we all die from radiation. Okay, so before JavaFX, there was just Java and Swing. I needed a multi-platform, platform-independent solution. It had to be extendable to multiple missions because it supports an onboard software system called GEONS, which is not Java, but it's all the ground system processing for that. And so I chose the NetBeans Platform because it was very well suited to file management, project orientation of files and services, which resonates very strongly with the mission operations model, which is, and NASA is typically data products in, there's some sort of procedures, validation, data products out, those data products go to some other subsystem. But I ran into a problem where the operators, they're the butts in the seats every day, day in the life, they're producing different data products and they don't necessarily know if they're good or bad. They're relying very heavily on automated QA from software like my own, but others, to tell them that it's good or bad. But if, as most of you probably know, just because you have software that can tell you if it's good or bad, it's hard to convey the why. Why is typically visually oriented. So the thought was, okay, well, now that I know I need some visual help here, now's my chance to use JavaFX because everybody keeps saying how that's what it can do. And so what I found was that, and I'm going to touch upon pros and cons in a second, but I found that using JavaFX really reduced my development time to getting very rich interaction out the door quickly and in a stable fashion. And I really can't I can't spend enough time, bragging about how great drag and drop event handling and manipulation is, but also how much easier they made clipboard maintenance, that sort of thing, than from how Swing was done before. And then, of course, the concurrency packages that are part of JavaFX made doing that in a not only easy, but made the GUI highly responsive, which is absolutely critical, because when I'm talking about data, I'm talking 6 figures of doubles being slung around as in multiple vectors around the screen. So I'm going to switch over to a view of the application real quick so you can have a feel for what the heck I'm talking about. No, that's not what I want to do. That's what I want to do. Okay, give it a second here. Okay, so I preloaded some data here, and what we have on the left is a pure JavaFX scene with a bunch of custom components. I've built very, very easily built in a lot of drag and drop event handling. I've created a menu item which, as it detects and calculates not only the data from the files, the data products, but also the secondary calculations, adds those vectors as pure first-class members of the data scene. And so now I can drag these and drop these into my charts and get a sort of Data Explorer type thing. For instance, I don't know why this would be useful because I'm just a dumb developer, not a scientist, but maybe inclination over Y position is valuable here. But maybe I want to see that same thing, but instead of the Y position, I want to see it crossed against the X position. And clearly there's a difference, and if I want to take a quicker look, I can do that. And adding all these animations was so easy to do in JavaFX. Now, where it gets a little thorny is when you want to try to take JavaFX type event stuff and push it back to the Swing side. On the right, that's not JavaFX, that's Whirlwind, and most people probably recognize that. And that is OpenGL, but it's also a Swing component. And so I had to facilitate a go-between to get communication back and forth. Here's a time slider, which is it's time in the data. These are all orbits, so to speak. And I've selected a certain time range, but over here, give it a few seconds because it's about to render 20,000 data points. What we have is the entire orbit system around the planet in a specific mathematical frame, and it's highlighted the same orbit track that we've isolated right here. So, but to do that, it wasn't hard, but it was tedious, and I want to get back to that in a second. But it is possible, and so if you have situations where you have some Swing controls you just can't part with, and you want to do new development in JavaFX, it can be done, and this is an example. The platform made my life easier because the visual element served that serves as this visual tab here for the platform actually doubled as my controller class, and it facilitates observable type communication between the two scenes. Okay. So to the pros and the cons. Yes, I can't talk enough about how easy it is to make very reactive GUI scenes with JavaFX. And of course, the time to do that has not only been reduced, but the code footprint in terms of maintenance is also reduced to do that. Now, reduced compared to what? And that gets me to my cons a little. That segues nicely. I can still do all those things with Swing, and I'm sure you all can attest to that. I can't think of a single thing that JavaFX provides that I can't do with Swing, unless I qualify it by say, do it easily and do it quickly. So if that's your goal, if your goal is to reduce the bottom line, in terms of cost, then you should absolutely jump in and dive in and look to start integrating JavaFX into your tools. Finally, I really want to say that I was a Swing guy. I remember Swing becoming the technology, and now I'm getting beat over the head because apparently it's not in a web browser, so it's not good. Although I can't imagine what my customers would say if I said, "Hey, NASA scientist, your next ground system is going to be Firefox. Here you go. You know, give us $1 billion." That's not going to work, and it won't work from an implementation standpoint. But it was very fun.
And the other point is, just because the application isn't running in a browser doesn't mean that it isn't interacting with the web.
That's right.
And that's an important distinction.
That's right. That's right. We are in a closed system. We can't fundamentally communicate outside of a DMZ. It's not classified, but for security purposes, we have to do it that way. So we can't really have web applications. There's no point. However, you saw the amount of data, it just doesn't work in a browser. And that's where JavaFX really steps up to the plate. But I just want to say that if we're going to get more adoption and we're going to get more people like yourselves, but also the kids coming out of school who've been brainwashed by their other friends that, you know, if it's not HTML5, it's crap. These are the three things that I think we need to drive at. They need to focus in JavaFX land on what ways they can reduce cost. If it's so easy to make something that's so great, why use another technology? And I'd really like it if they would pump some more support into 3D. Maybe get a JavaFX version of Whirlwind, that sort of thing. Thank you very much. Now you have to clap for everybody now. So don't. Too much.
Here we go. Well, my name is Timon, as Gert-Jan already introduced. I am the lead developer, architect of AgroSense, which is an open source farm management platform. Well, last year we won the Duke's Choice Award, which was very nice. So we are in good company, I think.
Closer to the mic.
I'm close to the mic, like this.
I think yours isn't working.
No. It's working now?
Yes.
No?
Yeah.
Hello?
Mine is on.
Yes.
Maybe give him
Maybe you want to switch. We just move them around. That will work. Yeah. It's no problem. All right. Can you hear me now?
Yes.
Yeah? Cool. All right. AgroSense. I'm not going to repeat everything. Well, it's a farm management application. It's not only used by farmers, it's also used by advisors, by big industrial farms, but also by standalone small farmers who want to experiment with precision agriculture. Because most equipment you can buy for your tractor and your tractor itself, it supports precision agriculture. But there are hardly any tools for them to support them in doing anything useful with it. So that's why AgroSense steps in. We want to provide this support for precision agriculture to as many farmers as possible. That's why we created this open source application. We have a standalone version for small farmers. They can use it for free. They can experiment how precision agriculture works. They can read all the data, visualize it on the map, and then do some basic analysis with it, and then send the detailed instructions back to the tractor. Well, there are also some big industrial farms and big advising companies around here, and they want to have some support for precision agriculture as well. So what we did, we also created a client-server version, and also it has a web client and mobile client. But for this purpose, we will focus on the rich client because it contains all the JavaFX and the Swing. So what do we use? We based our application on the NetBeans Platform, which gave us a huge advantage of not having to write all those great features it already has, like a windowing system, modularity. we used JavaFX. Half a year ago we had a discussion with the development team. Is it now time to move to JavaFX? And we had some discussions about it. What are the pros? What are the cons? We did not want to make the mistake of people who adopted JavaFX 1 and had to do it all over again. So we were a bit wary about it. But in the end we decided that it was time to choose JavaFX as our mainstream technique for new components. And it didn't mean that we had to replace everything we already had, because we could still use the Swing components. But for the new components, we could just use JavaFX, and it coexists very easily together. Well, we needed also to split the client and the server. And we discovered a nice, very new framework. It's not very mature, but it's called Open Dolphin. It's built by Canoe. It's very geared towards JavaFX clients and to have some synchronization with the server. And it really makes it easy to apply a good MVC pattern by using presentation models as the model part. And because they are generic, you can just move them back and forth, and there are really easy binding tools for it. So it made our life really easy. And it has some nice features I will show you in a minute. On the server side, we use OrientedDB for a graph database. And we use this because there is a lot of data in a farm. There's farms, there's fields, there's tractors, there's machinery that you can attach to a tractor, there are crops, and everything is connected somehow. But the connections always change. So we need to be able to have some connections to everything. So a crop is related to a field, and a field is on a certain location, and it has a time aspect. And so that's why we used a graph database, and it's working really well, especially in combination with Open Dolphin and the presentation models. So this is basically how it works. We have on the bottom right we have the server, and the server uses Open Dolphin to communicate with the client, and it has a model store which is basically a collection of the presentation models, and it will be synchronized between client and the server. So as soon as you start a client session, it will create a session on the server as well. So you can listen to all the presentation models in the model store on the server side, and you can do all kinds of logic on those models. And it's also really easy to sync two clients together because you have the data of both clients in one place. So you can listen to changes in one and propagate them to the other client. So I would like to show you now a field. How this works. Yeah. Here we have AgroSense. And here on the left we have Explorer. So this is what a farm looks like. It has some workers, production units, fields. And I drag one field on the map. I created one field. As you see, we have a central map component, and we can switch between several implementations, backgrounds. And this one is Virtual Earth. It's from Bing Maps. And it contains some really nice, very detailed photos. And it's very, well, if a farmer he wants to draw his fields, then he needs to have, you see all the ditches here, the water pieces and things like this. Well, I started another client, like this. And this one is showing the same field, only with OpenStreetMap background. So what I will now do is, here, this is Swing. This is the Explorer view we get from NetBeans Platform. This is really nice because you can organize your data in nodes and it will just be shown in the Explorer. This is our map component, which is also open source. We separated it from AgroSense so it can be used by other applications as well. You can just add it as a dependency in your NetBeans Platform application and you will end up having a map. And you don't need to add to change your application to have the map, but you can use the API. You can implement the geometrical interface, which basically says I have a geometry, and as soon as you implement this interface with your data object, you can just drag the object onto the map and it will show on the map. Here on the right side we have a JavaFX form. And as you can see, when I start removing it, this part and this part, it's all automatically synchronized with each other. That's because we do not, as a standard NetBeans application, we do not synchronize on nodes, but on the presentation models. So we use the data to bind all the forms to the data. So if you change it, and here you can see the other client, it's changed as well. So as soon as I start typing here, my other field, it will need some time, but the changes will be sent to the other client as well. And the really big advantage is this, is that when you're working with a team on, for example, an expert system, and someone is changing something, you can see actually the change happening. And then you can shout to your coworker, hey, don't touch that field, I'm working on that field. Or throw a pen to his head and say, well, you're touching my field. And it really works like the Google Word document. When you're editing together, you can really see where the other one is working. You can really prevent conflicts from happening. Well, another thing I would like to show you is some code. Because we are here at Java 1, so we need to see some code. This is one basic setup we use for the JavaFX form you saw on the other side. We are using MIG layout, which has a JavaFX version now as well. And this made us really easy to create very simple forms, because you can say, well, just wrap to, and after 2 components you add, it will wrap to the new line. So it's very trivial to add new forms. So this is the part where you add a label and the text field, and this is the binding. So now we bind the text field to the data object and vice versa. So you only need 2 lines to do your binding. And because you bind on the data object, if you have another screen that's also bound to the data object, if you make a change in one screen, it will automatically be updated in the other screen as well. So this is very, very nice. So we found out that we are much more productive with using JavaFX screens than we are with Swing, because things like binding are much easier to do in JavaFX. Is it time already? Okay.
There we go. Hello, I'm Rob Terpolowski. I'm with Linden Incorporated. We're a freight and logistics firm based out of Seattle and Anchorage. And I'm going to talk about our experience in developing a freight management application on the NetBeans Rich Client Platform with JavaFX. And not Duke's Choice winner this year. Wasn't even a runner-up. Yeah, maybe next year. So just a little bit about myself. Application architect at Linden. I've been there for about 10 years now, and I'm the technical lead for our freight planning and management application. FMS stands for Freight Management System, very clever name. And then a little bit about Linden. Linden owns more than 50 different operating companies that work in different markets, mostly in shipping freight to and from Alaska, although some of the companies have worldwide operations. Linden Transport's probably our biggest company. It's a trucking firm. Then Air Cargo and Air Freight are 2 of the other big ones, and then Alaska Marine Lines, which is our barge line. So we have to, when we develop applications, we have to satisfy a pretty diverse requirement base across all of those companies. So what's the problem that we're trying to solve here? Well, we want to help our customer service agents and our warehouse managers help our customers answer one seemingly simple question, and that's, where's my freight? That guy had a bad day. So we developed a desktop application based on the NetBeans Rich Client Platform. And in the first version of this application, we had two main modules. One was called Trace, which was for our customer service agents to help track down where freight is and the history of the freight to see where it had been in order to help our customers out. And then the other module is called Planning, which is more for our warehouse managers to see all the freight that was coming into their warehouse from the various locations and then the deliveries that they had to make so they could plan accordingly for resources, trucks, trailers, personnel at the warehouses and stuff like that. So what we're seeing right here is the Planning tab and the Planning module in NetBeans. Now, I know people in the back aren't able to read that, and I'm pretty sure people in the front aren't able to read that either because I'm having a hard time right here seeing what's actually on the screen. So this was developed with Jide components, which is third-party tools, swing components, and I think somebody got a little crazy with the cheese whiz here because they have like 4 or 5 levels of different nested tree tables, and so it's just a massive amount of information that we're attempting to show the user, and it's probably not really usable by anybody other than Chuck Norris, maybe. Definitely not by our users at Linden. So for this next version of the planning module that we want to develop, I'm going to be looking at using JavaFX because there's a lot of cool things you can do and ways that you can represent the data. You can create metaphors with JavaFX to model the problem that you're trying to solve, and really those are only limited by your imagination now at this point. So a couple of the goals here were to use Scene Builder as much as possible for the WYSIWYG design. I have a slide for that. And then also use cascading style sheets. So I really wanted the project stakeholders and the developers on the project to kind of think outside the box what's possible to do when developing these user interfaces. So I came up with a few concept screens just to kind of get them thinking before we set out and actually work on the design the final product. And so what we have here is a screen that kind of looks like, on the top portion, you have what looks like a airport, or train station arrival board. So the managers could see, this would be for Anchorage, and the managers could see, okay, what are all the trips that are coming into my destination, along with the mode of transport, rail, highway, boat, barge. And then they could select a trip, and down below they'd actually see the shipments that were on that trip. And so all this was pretty much used with stock components out of the core JavaFX libraries. Some of the components on the top are out of the JF Extras project, which is an open source library. So this is one of the things, and you can put effects on here that make give the user interface a real sense of realism, like drop shadows. Gives the components really a feeling of depth and realism. And then the second cut we had here, it's refined a little bit more. We have the different modes of transport up on the top of the UI, somewhat like tabs, and we're able to apply these effects to these components, such as the reflections or the slight glow around the steamship tab that's selected up there, and then also on the unit plans, I'm not sure how good it shows up on the screen, but those components are a little bit glossy and translucent, so you can kind of see what's underneath them. And as Sean kind of alluded to when he was talking about his application, this stuff is doable in Swing, but is so painful to do. And it's pretty much baked into the JavaFX framework, and using Scene Builder, it's really easy to apply these sort of effects to the components on the user interface. So then moving to Scene Builder here, you can see the design of the application is getting refined a little bit more. But this is the WYSIWYG tool that we've been using. And behind the scenes, it's generating XML. It's not generating Java code. So that's something, that's a caveat, and I'll talk a little bit more about that and integrating that with NetBeans. But basically, it's drag and drop. You got your components over there on the palette, and these are the JavaFX core components out of the JavaFX library itself. My biggest gripe with Scene Builder 1.1, and I'm not sure if this is going to change in 2.0 or not, but you can't add custom components to the palette in this version of Scene Builder. So we developed some custom components. We weren't able to drag and drop them onto here. Same thing with the components from the JFXtras libraries. We're not able to get those into the UI here in Scene Builder. So what we have to do is we have to go manually add them to the XML file. And then, which isn't too hard to do. It would be nice if you could do everything from Scene Builder. But then once those are in the XML file, if you go back into Scene Builder, it renders them just like as if they had been dragged in there. So given that Scene Builder generates XML behind the scenes, then how do we get this JavaFX user interface into the NetBeans platform? So the cool thing about NetBeans is it's a modular architecture, so we can change the planning module of our application without affecting, the trace module or any other modules that we have running in there. So I was kind of surprised at how easy it was to actually add the JavaFX UI to the NetBeans application. And this is probably hard to read, but I'll just paraphrase it really quickly. You have an XML loader class in JavaFX, and you pass it the path to your XML. It takes that, reads it in, and converts it to a JavaFX component. There's a special type of JPanel called a JFX panel, which can take as one of its arguments a JavaFX node, or a scene, I guess it is. And then once you put that JavaFX component onto the panel, then you can add that panel to your Swing UI just like you would any other Swing component. So pretty easy to do. So then finally here we have kind of the finished product of this the first phase of our next version of our planning module. We have that JavaFX UI embedded now into the planning component that was previously housing the nested JTable user interface. So that is pretty much it for me. My contact information, if anybody has any questions about this.
I actually do.
Okay.
Rob, can you go back one slide?
Sure.
Can you just, for everybody, because I can tell, but can you highlight what parts are still Swing that are visible and what are not? Actually just focus on that?
Sure.
Which
so on the UI right now, what you can actually see, not very much of this is Swing anymore. We still have the menu up at the top right there, which is a regular J menu. And then the tabs themselves are the part of the NetBeans top components architecture.
But in this case, you could remove that tab since you only have one. Or do you need to have multiple?
No, we still have our trace module, which is the customer service one, and that one's still using Swing as its base. But I haven't shown it here. You can see the tab up there, but I haven't shown the contents of that tab.
So how many help desk calls are you going to get from your customers saying, complaining about that tab being Swing instead of JavaFX?
I imagine a lot. So it'll probably become once this version goes out, I think it'll be a higher priority to start moving our other components over to JavaFX and make them more visual appealing and user friendly for our users. So there you go.
So one reason why I find the desktop so interesting is because there's such a variation of things being done with it. I mean, in one session we have logistics, farm management, and NASA. Whereas in the world of the web, you're doing like probably 70% retail, and the rest is hotel reservations. I mean that. And the other cool thing is that there's clear synergy between at least the farm management and the logistics story, except that the logistics story is probably specific to Linden. But there is a logistics aspect that's relevant to farm management. And quite often when we're Java 1 and people with the same NetBeans platform background meet, they end up exchanging features with each other because they have the same basis. Anyway, are there questions? In addition, here are all our contact details. Tomorrow there's a session to give some background on the container part that was used in the various JavaFX scenes that were shown, giving a window system and a module system. Questions? Yes.
Since the
JFX panel doesn't repaint with dirty regions, it always repaints everything. Did you guys find any issues with performance?
No, our application isn't doing a whole lot of data crunching and updating the UI and that sort of thing, so we haven't run into any performance issues at this point with the JFX panel.
I have more problems with Whirlwind, honestly, and that's OpenGL, so if that tells you anything, you know.
What about, most of you use, all of you use NetBeans Platform. So the question is, what about packaging? Sure, NetBeans Platform works well with Swing, but with JavaFX, I know without using the platform, unfortunately, I've had some issues. You know, it's an external tool, and it's sort of that guy has JDK6 installed, etc.
Okay, let me first repeat the question. The question is the packaging. How does one package the JavaFX parts of the Swing JavaFX application? And is there a feasible solution for that?
Yeah, so what we're doing with our installer that we're creating for our application is we're actually bundling with JDK7 with the installer, and then the application uses that private JRE for its when it's running.
No, I'm not. No. We have, I'll try to speak up. We have built the standard NetBeans Platform installers. We're using that. And we have built in a check to check if it's the right version of the JDK. And it will provide links to update if you're not. And it's hard because as soon as you pack the JDK with your application, you're also responsible for updating it. And that's a bit of a downside because every security update you need to monitor very tightly and provide a new version of your application also with every JDK update, runtime update.
Yeah, and for our case we have control over our users' machines, so we can, if there is a JDK issue, we can push out a new version.
We're a development environment, so we don't have any control.
Right.
Exactly.
So another question back there, yes, and then here, yes.
Yeah, so you went from using a lot of sort of data-rich sort of JIVE components, the tables and stuff like that. How did you find the transition from going to that to using just the more basic JavaFX components? Can you still really customize renders and editors and all that kind of stuff within the JFX tables?
Yeah, so that's a good question. That's
Can you repeat the question?
Sure. So going from Swing to a data-rich Swing user interface to JavaFX, how easy is it to customize components like table cell renders and stuff like that? So it's the same sort of concept in JavaFX. You do the code. You can do the coding in the XML, but then in Java, if you need to customize the tables for colors or different texts or anything like that, you can plug in your own cell renders and editors into that. And so that's something that we're going to be looking at doing as well as we continue moving along with this project, is to make these tables a little more user-friendly as far as giving feedback to the user on shipments that might be in jeopardy of getting delivered late or something like that. So we will be developing those sort of tools for JavaFX as well.
Question up here.
Yeah, the previous session talked about testing with JavaFX. I'm wondering if you could talk about your experience. Is it easier, harder, or the same?
Yeah. There was a very interesting, I think Timon at least saw it, a TestFX developed by the group that presented the previous session.
I definitely took a note because it looks very interesting, and up till now Swing is hard to test, Swing UIs, and well, JavaFX UIs are also hard to test currently. So what are we doing? We're not testing them automatically. We just do the user tests. But it would be very nice to have some automated unit tests for the UI as well. Yeah. So you at least know that the basic components are working. And the TestFX, it looks really, really nice.
But also with the NetBeans Platform, we have a UI testing framework. So the question would be how to combine that framework with the TestFX. Or we wouldn't need the TestFX, and we could somehow move up the component hierarchy to find the JavaFX components contained within the...
I think we won't do the integration test automated, right, because Well, you can test one component and you know what to expect, but since it's a modular application, you never know what to expect and you never know what configuration the user has, so you have to do some manual testing.
Yeah.
Yes.
I'd like to add though, I'd like to add to that though that one of the code footprint when you're doing these types of things in JavaFX is much simpler and smaller. So there's, in my opinion, much less risk. You know, tighter, smaller, more concise bits of logic are easier to test in general, right? So you can take a little heart in that. So if you're worried about jumping into JavaFX because it's harder to test, it's actually going to be much simpler code. So you'll have a much better mean time for failure.
Yes, another question up there.
Are you aware of any limitations of JavaFX or areas where it needs improvement for scientific?
The question is actually one. I mean, this is the key question. What are the limitations, and are those limitations such that they prevent you from being involved with JavaFX?
I think Sean might want to answer.
I think Sean might want to. I think Sean might want to say something.
Well, I'll defer if anybody else would like to jump in real quick.
Well, go ahead.
You don't dare.
You know, okay, so I had a lot of problems at first using the charts with huge amounts of data. Now, what is huge? One man's huge is another man's a trivial amount, right? But the charts that you're seeing up here, that I showed up, they are the standard JavaFX charts, and each vector has 20,000 doubles, okay? And so every time I dragged a vector and dropped it on an axis, and then it picked that up and then jacked it into the chart or updated the chart, it's jacking in 20,000 doubles against 20,000 other doubles, potentially, whether it's I'm sampling in time or as a function of another vector. So you're talking about 40,000 data points, all doubles, being cranked into these scatter plots that did not respond so well. And so what I found was on this machine is an i7 Core 4, so it's not the best machine in the world, but the responsiveness was like 3-4 seconds, okay, just to get those in after the drop action had occurred. And that's acceptable, but then what if you want more? I mean, honestly, 20,000 data points is that's not enough for what we do. That's just to get started. And so what if you wanted to automatically chart maybe 6 or 7 different classic views that are very standard in the aerospace industry? I originally started trying to chart on 8 charts, 2 axes each, and so it came out to something very close to 200,000 data points. And I timed it at something like 2 minutes it took to render. That's just not acceptable. And so the reason is because these charts are all managed charts as part of the scene graph. So every single data point is a managed node in the overall scene graph. So you get all the nice animation, you get the automatic updates, you get all the event handling, you get it all for free. And everybody says that's why I like JavaFX. Except there's a cost. And so if I had my way, what I would do is I would create a version of these charts which is an unmanaged version, maybe even a canvas-based version. Maybe it's a mode that you can set it in where when you add a point to it, it translates it to a canvas and just jacks the pixels in. That's it. And if you want special event handling, you got to do it yourself, right? I mean, things like JFreeChart and some other swing-based ones have already started releasing components that do that. So to answer that question, it caused me a lot of consternation and heartburn. And eventually, the only solution I could really come up with was I had to put in sampling rates. I can't show you. I keep clipping on my screen. I had to put in sampling rates and then let the user say, I want 1 in 10, 1 in 5, 1 in 40. And for most applications, that's acceptable, but there are going to be situations where you just need 1-to-1.
Are you aware of project names for that code? You said JFreeCharts with the same components.
He asked if I'm aware in a JavaFX session about a swing project. It's part of if you check out JFreeCharts, they have a high data density thing. They just announced it a few months ago. But I'm telling. It's not a JavaFX component. It's still a Swing component. Now, I'll tell you this. I worked with Carl Dia, who also is a JavaFX author. He couldn't make it this year. He apologizes. He lives in Maryland with me, and we kind of busted out a really simple canvas scatter plot control. And it's really easy, actually, in JavaFX to just do a simple, here's a box, 2 axes, throw some pixels on the screen. We were able to achieve 250,000 data points in less than a millisecond. In fact, I couldn't. It wasn't even. It was measured in hundreds of microseconds. So, it was certainly rough and it wasn't production quality. But if you really are worried about the quantity of data, there are solutions, but you're going to have to hand tool it for now.
The low-level components in JavaFX, they can handle a lot of data, and they are really, really fast. So it's a matter of being aware of the amount of data you're processing and choose the proper component.
Agreed. I'm not criticizing the performance of JavaFX, just of the use case I tried to force fit on those managed charts. What?
Tabular data. The question is, what about tabular data?
As in tablets, or wait?
Tables.
Oh, I honestly haven't had to deal with tabular data of any significant quantity. Most of my data has come in this form, and honestly, the hard part is getting that data in and out. It's not really a JavaFX thing per se. That's just a Java thing. And of course, so Java 7, and then eventually, I can't use Java 8 because I have a code freeze in April, but Java 8 has all that stream processing where you can do these things in parallel. I don't really think you're going to have a problem. I think if you do it right, you'll separate that out of the JavaFX world and then just use the nice concurrency support that JavaFX has to load rows as they appear.
So the question is, with the logistics app, how does the tabular data scale? Yeah, we're not working with a huge amount of tabular data either. We're talking about maybe a couple thousand rows, which, in my opinion, isn't a whole lot. So we haven't seen any performance issues with tables in JavaFX.
Bunch of more questions coming. Okay, so on the left here.
Yeah, because the worry is, and I think I see your point as well, is in a table in JavaFX, those are nodes. Each particular cell is a node, right? So if you have, even if you have a 500 by 30, you're talking about, 15,000 nodes, plus their text handling and their order handling. So the question is, have any of you had to deal with that type of scale?
I've had to deal with that in Swing, and it's easily solvable, right?
And Swing is very good because you don't have cells, you have renderers to scan the cells because they run into this performance. And I wonder, has FX done that for their tables yet?
Well, the concern is that each cell is a node in JavaFX, and I don't know if somebody out there gone into some of the other JavaFX sessions, but as the number of nodes increases in a scene graph, the performance decreases, I guess, is the concern. But no, we personally haven't run into that issue yet.
That's what I would do.
Yep, in the back there.
Have you actually tried to take existing sort of extended classes or tables and things like that? You've already got a whole bunch of implementation and simply just try to change its extension in superclass to one of the JFX panels and sort of try to figure out the compiler bugs from there and work with that? Or are you guys completely homegrowing everything again, trying to reintegrate all that special behavior you had in Swing into JavaFX?
So the question is, are we going to do we try extending, instead of extending JPanel, for example, extend JFX panel and then try to port the JavaFX components over that way? So from our point of view, we haven't done that. We pretty much are starting from scratch with that one tab that I was showing there. But for the other module that we had, the customer service module, there's a possibility that we would look at, doing it piecemeal, where we tried converting widgets over one at a time. But I'm not sure if we'd go the route of just, creating a JFX panel and then that, or if we're going to, do something up in Scene Builder and then just, throw it into the UI.
I think Timon has an interesting approach as well.
We try to do that for a few components, but in the end, it was just much easier to just create them again. Because there is not, it's very granular, the application, because everything is nicely packed in modules and screens. So it's not a whole lot of code you need to refactor. So if you want to change one component, it's just a few fields. It's not hundreds of fields.
And the other thing that you said before is that as you add new features, those new features are JavaFX.
Yeah.
And you're not going back and changing all the swing to JavaFX, but only when you're actually working on a particular component that is a swing.
We leave all the, because they mix so well, and you can even have a, the tabbed screens in your property screens. You can have one tab being JavaFX, the other one swing, then another one JavaFX. And you can even add a new version of existing functionality and just show it in parallel to the existing swing functionality.
So I think what we need is CSS style sheets for JavaFX to make JavaFX look more like swing.
Yeah, that would maybe help the adoption for the end user, to gradually provide the icon. Yeah.
Okay, yes, a question there. Eric.
Yeah.
So this 4 or 5 second delay to render the 20,000 data points, is that on the EVT? Does it lock up the rest of the UI?
It was being executed in the application thread in the JavaFX land because all the actions were occurring in the JavaFX scene. So I didn't really have to go outside of that. But yes, and no, it did not lock it up. I set background, the equivalent of a runnable for that. So it's run later. I don't have the code in front of me. It's stupid simple. But it's a little bit of a pain because you have to take that into account whenever you have any manipulations. Unfortunately, because you're in a different thread, you have to take into account situations like, well, do I have access to this variable? Do I have to declare it final? That sort of thing. Well, it's not 20,000. It's like 19,000. It's not that bad. But but you can take all that into account, and if you're smart, you can encapsulate that very easily in your standard getter setter type model, and then it's all taken care of. And so that's kind of the approach that I took. But I also, I didn't do full replacements like these fine young cannibals over here. I approached it where all my components were JFX panels. I create JavaFX components, and then I have a separate class layer, which is just a JFX panel, which facilitates just that. So I have JavaFX components that don't know anything about swing, and of course, my swing components, they never know anything about JavaFX. I always keep the I know everything type stuff in the JFX panel class. So that's my model, and it seems to be working for what I have to do.
Okay, I'm sorry, I think we need to wrap up. If there are more questions, please feel free to come up and talk directly with the panel. Thank you very much for coming.
Thank you.